Hello, welcome to the channel. We are continuing our sequence on integration by parts. There is a playlist which contains all of the videos on this topic. I'll put this link to that playlist in the description. So today we have an indefinite integral, and unlike the last two exercises that we did, here the first idea that comes to our minds, which is substitution of u is equal to ln of x, actually works. Like in the last example, we had sine of ln of x, as far as I remember, and there we didn't have an opportunity to use this substitution because we would have problems with dx over x, since the derivative of ln of x is 1 over x actually. But now you can foresee that we have dx over x there, so if we will make substitution of u is equal to ln of x, we won't have any problems in getting rid of x's and transitioning to the integral of something containing du only. Alright, too much of words. Let's write these things rigorously so that you can catch this up. So what I propose is writing u as ln of x, then du will be 1 over x times dx. And in this case our integral will turn into an integral of ln of u, and since dx over x is du, we just have du here. Now the next step is to evaluate this new integral that we found, and for this we'll use the trick that we used in the last two videos of this sequence. It's the trick that we can express the function as that function times 1. In our particular case, it's ln of u times 1 du, right? We do this to use integration by parts. Indeed, it's not necessary to write 1 here. We can just take du as our dv, but writing 1 gives more of a feeling of what we are doing right now to most students. Alright, now we can use integration by parts, and we can take ln of u as the function we'll find the derivative of later on, and 1 times du as the function we'll find an antiderivative of. Now in integration by parts we have the form. Alright, there is a method I was using all the time, like most of the times in my previous videos, in which I don't write du. Like I try to avoid u and dv notation. It's pretty much the same thing as normal integration by parts, except we're saving some space and do this in our minds only. You can go to those videos to look to that. Now, since it's kind of a new video to the new viewers, I prefer writing everything in details. Right, so we have u as, let's take some other variable because we used u already here. Let's take w or omega as ln of u, then d of omega will be 1 over u times du, right? Meanwhile we have dv, which is 1 times du, then v is just u, right? We just like take an integral here and have u here. Now we want to obtain the form in integration by parts of w times v minus an integral of v times d of w. So summing up all these, we have what? It's u times ln of u minus an integral of 1 over u du times u, so basically it's just du. Let's write it's u times ln of u minus integral of du, and some of you already can see the final result. Nonetheless, let's first write this integral of du, which is u solely, and add some constant c, which is important. And this is the point where some students stop, and it's actually a mistake because it's not a definite integral, it's indefinite one, so we need to have all the variables as was in the beginning, because in definite integrals we have just some values. So for the time being we have variable u, so we make a back substitution to x. Well, remembering that u we took as ln of x, we simply put ln of x instead of u. So we'll have ln of x times ln of x minus ln of x plus some constant c. To avoid some confusion, let's add some parentheses here. Okay, and it's our final answer. If you have any questions regarding this exercise or any other one in this channel, please feel free to write them in the comment section below. And see you on the next videos. Bye.